Hey, hello, and welcome to today's GFG problem of the day. Strings count. Let's see what the problem has to say. Given a length n, count the number of strings of length n that can be made using A, B, and C with at most one B and two C allowed. Okay. So what the problem is trying to say is, let's say if n will be the input, right? If n is 3, so what the problem is trying to say is we have to make string, right, out of A, B, and C such that there are conditions, right? There can be at most one B, right? Right? And at most two C. At most means that it can be either 0B or 1B max. Here it can be 0B, 0C or 1C or 2Cs, right? 2Cs at most, right? So, yeah, so we have to, for example, if n equal to 3, right? So what can be the combinations, right? One combination can be all A's, right? All A's, right? Right? Without any B or C, right? All A's. Second can be two A's, the combo of two A's and one B, right? Third can be two A's and the combo of one C. Fourth can be 1A and 2C, right? So these can be the combinations. Definitely this particular, like all this, right, can make multiple combinations of strings, right? For example, if we take this, right, so two A's and one B, so the placement can be AAB or ABA, BAA, right? Yeah, there can be multiple combinations, so we have to output the number of combinations, right, with A, B, and C, right, with the given conditions, right? So the expected time complexity here is O of 1, and space complexity is also O of 1. So how can we achieve this, right? The time complexity and space complexity, that is constant, right? How can we achieve this? So we have formula. We have formula n factorial, p factorial, q factorial, r factorial. So we have formula like if you want to arrange something with n combinations, with n objects, right? Right, with different combinations of n, right, such that p is uh, p is one type of object, right? Q is another type of object and r is another type of object. So here p, q, and r are what? A, B, and C, right? A, B, and C. Okay. So if you want to find all the combinations, right, of n type of objects, right, of n type of objects, right? So this is a formula for that. Okay. So let's see one by one, one by one. Okay. So for example, right, the first case, as I said, all A's, all A's. So it can be definitely whatever is n, right? Whatever is n, right? If n is 3 or 4, for example, then what can be the or what can be the possible combinations of all A's, right? If n is equal to 3, it will be AAA, or if n is equal to 4, it will be AAAA. So one combination, right? It can be one way only with all A's, right? So when it is all A's, it will be one way, right? Then second is two A's, for example, if n, right, given n, it will be n minus 1 A's, right, and 1 B, right? Why n minus 1? Because the B is taking one position. That is why n minus 1. Okay. So sorry, yeah. Okay. So according to this given formula, right? According to this given formula, what it will be? N factorial, right? N minus 1 factorial. That is, this is A's, right? And 1 factorial, that is B's, right? So what it will be? N into n minus 1 factorial upon n minus 1 factorial, right? Which will give us n. Okay. So with this n minus 1 A's and 1 B, it will be n ways. Okay. Similarly, the third part, right? When n minus 1 A's and 1 C, right? So according to the formula, what it will be? N factorial, right? N minus 1 factorial for A and 1 factorial for C, right? So it will again be n into n minus 1 factorial upon n minus 1 factorial, right? It will give us n again. Okay. Then we have the fourth one, right? The fourth one, it will be in two parts, right? One will be, right? One will be uh, n minus 2 is, right? 1b and 1c, right? At most, right? At most 1b and 1c combination. So what it will be? N factorial, right? N minus 2 factorial. 1 factorial for b, 1 factorial for c. So it will be n into n minus 1, n minus 2 factorial upon n minus 2 factorial. So it will be n into n minus 1, right? So this is fourth, right? First part of fourth. And second part can be n minus 2 factorial of, sorry, not factorial, n minus 2 is, right? And 2c, and 2c, right? At most c can be 2, twice, at most 2, right? So what it will be? So what it will be? Oh, so sorry. Okay. So it will be, um, yeah, n factorial, right? N minus 2 factorial for A and 2 factorial for C, right? So what it will be? N into n minus 1 into n minus 2 factorial, n minus 2 factorial, right? 2 factorial, right? It will be finally n into n minus 1 upon 2. 2 factorial is nothing but 2 only, right? So our formula boils down to this, right? Boils down to this four, what do we say? Yeah. So what it will be if we consider all these four combinations, right? One plus one way, right? One way plus, then we have n, second and third n, right? So it will be 2 into n, we can say, right? N plus n, nothing but 2 into n. And then this fourth one has two parts, right? 1 and 2. So the first part gives us n into n minus 1, n into n minus 1, right? N into n minus 1 plus this part gives us n into n minus 1 by 2. So simple. So this is the solution. Return just this combination. Okay. So let's quickly see. Yeah. So here it is. We have already, I have already, yeah, implemented this. So as I said, we have derived this, right? We have derived the formula, right? So let's submit. So yes, it is accepted. So also it adheres to the time complexity O of 1, right? And space complexity as well. We have not taken any extra space. Okay. So thanks for watching. Please like the video and subscribe to my channel. Thank you so much.